This is my BCD to 7-segment display. It's all done with relays and some core rope memory. And BCD is binary coded decimal, and it's just a method for storing decimal values 0 through 9 in four bits of memory. Okay, so here's my 4 bits over here. This is the one binary. This is 1. This is going to be 2. This will be the 4, and this is going to be 8 here. So binary 1, we get a 1 out here, and this is going to be binary 2, we get a 2, and then 1 and 2, we get a 3, and then this is binary 4, we get a 4, 4 and 1 here, we get a 5, and then 4 and 2, we'll get a 6, and then add a 1 there, we'll get a 7. Turn these off. This is 8, we get an 8, and then 1 more over here, we'll get 9. Okay, so we're taking these 4 digits to 9 now. We want to get a 10. We're going to have to add another unit here, another display. And if we turn that off and we go to 10 here, if we wanted to, we could make an A and go to it would just be hex to 7-segment display, and we could go we could get up to F here, I think, but that would be A. But we don't want to go hex to decimal. We want to go by BCD to decimal. So I'll show you how this works, and then we'll show you what we can do to get another unit in there. So here we are here. Can you see that? And so here's our core rope memory, and here's our 4 switches right here. Okay, so let's just start with the 1 here. We turn this on. This is going to be a 1. This is R1 here. This turns this one's actually R1 here, and it comes up and it just goes through B and C here, and this is B and C, and that gives us a 1. And then it goes over to a 50 ohm resistor that goes through a MOSFET to ground, and it's just controlled with a PWM. So you need you can't have DC going through there. You need some AC going through there, right? So that gives us a 1, and then let's skip down to this one here. This digit here is going to be an 8. Of course, when we turn that on, 8's up here. 8 goes through everything. Everything lights up, and that'll give us an 8 there. So each relay is going to be 1 through 9, and then sometimes you have to eliminate another relay that's on. Say if the 1's on and you don't need that on in this position here, you have to eliminate it. So so that you don't get the wrong digits in there. So I have 9 wires running through these cores here, and one for each number there. Okay, now so that's pretty straightforward there. And these I found that these are 100 micro Henry inductors, and these two are these are 100. These are 100. They're the same thing, 100 micro Henry inductors, but the core is different on these, so they're not quite as bright. These have iron silicon aluminum cores, the black ones, and they work better. These two are the yellow cores, but these seem to work better. Anyway, I ordered some more of those, and if I want to continue this to a 2nd digit here. So now here we got. Here's what we have to do and what they do to change the BCD to decimal. Okay, so what happens with the 4 digits? It can actually go up to 15. 1111 is going to be 15. Okay, now if we have a 10 here and we start to shift it into, this is our first unit, and then it's going to be our 10 unit. So this is one of the displays. There's going to be another display here. And if we start shifting this in, and these are shift registers here, we're going to shift them over there. So we shift this over, we get a 1 there, that's fine. We shift it again, we get a 10 there. Now we shift this one more time, we get a 0, 1, 0. So that's going to be 5, right? Now if we shift it one more time, it's going to come out to 10, okay? We can't have a 10. We have no 10 in this 0 to 9. you know, I mean, it's going to be hexadecimal A if you want, you know, but we don't want that. So we want to shift at 10, okay? Now, these registers, it basically wants to shift at you know, 15 and you add 1, so at 16 it wants to shift, right? Because you have 1, 1, 1, 1 is 15, add 1 more, it's going to be 16, it's going to want to shift that into there. We want to shift at 10. So what we do, the rule is, it's called Double Dabble, and it's an algorithm is used to convert the binary to BCD, okay? So what they do is they take, if the unit is, this unit here, the first one, is 5 or more, we add 3 to it, okay? This happens to be 5, 1, 0, 1, that's a 5. We add 1, 1, that's a 3, right? And then when we add these together, 1 and 1 is going to be 0, carry the 1, 1, 1, 0, carry the 1, 1, 1, 0, carry the 1. So it's going to be 1, 0, 0, 0, and it's going to be an 8, okay? We added those together. And, you know, 5 and 3 is 8, okay? Now, we shift it again. We put a 0 here, we shift it over. We're going to get a 1 here and a 0 here. We're going to get a decimal 10. That's what we want, okay? So the reason they add the 3, so, you know, 4-bit binary, it likes to shift at 16, okay? And we need to shift at 10. So, you know, 16 minus 10 is 6, okay? And shifting left doubles, so we go from 1 to 2, 2 to 4, 4 to 8. That's always doubling. So we add 3, and that'll shift the nibble. These are nibbles, and at 10, so it shifts at 10 then. So, and kind of a neat little thing they do, but that works, and we shift that over to 10, so we get our 10 there, and that's how they actually do it, and that's called Double Dabble. We're doubling it, and we got to dabble a little bit. We got to add this when it's units 5 or more. We have to add 3 to it. So that's how they do it. How I'm going to do it might be a little different. I'm going to have to add another row of these and some more relays and another unit here. But for now, it's working. I can go, you know, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and if I do a 10, I get an A, and which is hex, but that's fine for now. Anyway, thank you, and it's all done with relays and core rope memory, and of course I had to use some little electronics there for my PWM there. Anyway, thank you.